So good morning, everyone. Thank you all for being here. Thank you to the DevFest organizers, and thank you to this crazy group, Bagarotech. I am member of Bagarotech, so I will talk about it later. And yeah, before I start, I want to do a quick check of the room. Be honest with me, because this is between us. How many of you came to this talk hoping that I would tell you that AI coding tools are overhyped, they cannot really replace developers, that you can relax and go back your day? Some of you? Yeah, just one maybe. And yeah, the other question, how many of you came hoping for the opposite? So that these tools are the future and all your less curious colleagues are about to be very embarrassed? Another one, yeah. I think, yeah, both of you are going to leave a little disappointed today, so I'm sorry in advance. So, as she said, my name is Andrea Della Porta. I'm a mobile manager at Capgemini. And for the last several months, I've been deliberately using AI tools for mobile projects, real mobile projects, not demo, okay? Claude Code from a topic, OpenAI Codex 2. Little spoiler, I prefer Claude Code for now. And before I show you anything, I want to talk to you about the social media, because let's be honest, if we give a talk on LinkedIn, we can see that half of this room probably has already been replaced and just does not know it yet. But if you read Twitter, the other half is about to lose their job. Because a 16-year-old with a Cursor subscription and 3 days of YouTube tutorials can do everything. And if you read the hacker news, none of this actually works. The demo are all faked, and we should be writing assembly anyway. So I've used these tools in production, sorry, and on the project I'm showing you right now, the weather app, we will say it. So I think this talk can be called like the honest version, okay? The Tuesday afternoon version, okay? So here is what we will cover. The first one, why mobile development specifically is a different beast for AI assistant compared to, I can say, a Next.js web app, okay? 2, how to structure your project so those tools actually pull their weight, okay? And 3, live coding, and I mean live coding, not pre-recorded, where you will see prompts that work, prompts that probably will not work, and the moments where I have to take back control. And 4, how to review AI-generated code without becoming a rubber stamp and without becoming a paranoid bottleneck. So I can say by the end of this talk, you should walk away with a workflow you can try on Monday morning, not a philosophy, not a manifesto, a real workflow. Yeah, just quick logistic questions at the end, please. And if something goes wrong with the live demo, because I will try Claude Code and a little bit of Codex here, and we are at a DevFest, so something always goes wrong with a demo, please appreciate the authenticity, and we will keep moving. So let us start. Okay, the first point is this one. I want to address something up front. Most of the AI coding context and content you see online is written by web developers for web developers. Okay, so Next.js, React, TypeScript, that's fine, but it's really different. Mobile is really different, and the difference matters when you are working with AI, okay? We can talk about these 3 points. The first one is the feedback loops. So on the web, when an AI changes something, as I said, it's different from mobile because you save the file, basically the dev server auto-reloads it, and you see the result in like, I don't know, 2-3 seconds. On mobile, you might be looking for a Gradle sync, an Xcode rebuild, a simulator tool. If you are very unlucky, a 45-second incremental build. If you know Android Studio, you should know something like that. So you cannot afford to try and see the way web developers do. The second one is related to the platform fragmentation. So the project I'm going to show you today runs on Android, iOS, desktop, and web too, because it's a Kotlin multi-platform code base using Compose multi-platform. So that is 4 targets, 4 sets of platform convention, and 4 sets of edge cases too. So AI tools, we can say, are working very well on Android and iOS in isolation, but ask them to write code that works in the common MAE, so with a Kotlin multi-platform project, and you will see there will be some problems, okay? And the last one, tooling. Yeah, a web AI assistant, can run an extraction like npm test in a sandbox and iterate. A mobile AI assistant can't do that because on iOS you need Xcode, a real device or simulator, signing, provisioning, all the things we know about mobile. So it cannot just try things, which means AI is operating with less feedback than it gets in a typical web usage, okay? So the important thing is you, the human, are the feedback loop. So hold on onto that idea, please. The human is the feedback loop. That is actually the central thesis of this talk, okay? Everything we do, the way we structure our project, the way we write prompts, the way we review the code, is in service of making that loop as fast, as accurate as possible, okay? There is a good news too. The techniques I'm going to show you today are really good for all the platforms. So for Android, native iOS, Flutter, React Native, Kotlin multi-platform, it's obvious. So the principles are the same. I'm going to use a Kotlin multi-platform app with all the 4 targets, okay? If it works in this app, it works everywhere. So this is the app, okay? It's a weather app. If you saw some of my other talks, I always use this app that is an incremental app because on each talk I'm adding something. So it's real, working, public on GitHub. I will share the QR code later. Compose multi-platform on the UI side, Kitor for networking, Coin for dependency injection, Voyager for the navigation, clean architecture with data domain UI layers, about 30,000 lines of Kotlin. It's deployed via 7 separate GitHub actions, so it's a real app that can be shipped in production, and it's our code base for today. And this is the code base the AI is going to work in today. So now let's talk about the what makes a project AI friendly, okay? Okay, here is the, how can I say it? Here is the mental model I want you to adopt, okay? When Claude Code or Codex, for example, starts working on your repo, I can say it's like a senior developer joining your team on day 1, okay? So if a senior developer is joining your team, we hope he is really smart, or she is really smart, that he can write a lot of Kotlin and a lot of Swift, but they never see your code, for example, no? Your conventions, your deployment process, your product, basically. So you will have a first question to him. What would you give a senior developer on day 1? Maybe a README? How many of you are using a README file on a real README file on your project? Yeah, perfect. That's really important because you will tell them where the architecture lives. You will tell, I don't know, the conventions as I said previously. So that is exactly what an AI assistant needs. Yeah, sorry. And both Claude Code and Codex have a convention for this. Okay, perfect. Let's start with Claude Code. Claude Code reads a file called claude.md, okay, at the root of your repo. And you can add also some other claude.md files in the subdirectories. And Codex basically has the same file that is called agents.md. So the format is essentially the same. plain markdown, conventions, gotchas, build commands, whatever you want. In fact, you can mostly write one, maybe the Claude one, and then symlink the others, okay? Let me show you what that looks like in a real project. Okay, this is the weather app project. As you can see, here we have the Claude.md, okay? And here you will see that the first section is related to the project overview. Some paragraphs about it, not a marketing pitch, just facts, okay? This is a Kotlin multi-platform weather app targeting iOS, Android, as I said previously. The shared module is compose app, platform-specific source set follow KMP convention. Yeah, the second section is about architecture. So we are using the clean architecture, core data contains repository, mappers, DTOs, core domain contains models, obviously, repository interface, and blah, blah, blah. Okay, that's it. Some sentences about the architecture, some sentences about the basic structure of the project, and then you will see we have other sections created by Claude, and not only, we will see, about conventions, localizations, how to add a new feature, for example, no? How to build, test, and run this application, how to, yeah, as I said, how to test it. Here we have the gotchas. Here we have what not to do, and other little things. Okay, so this is really important because when you will write a prompt on your Claude Code tool, this is like a Bible for it. Okay, so it will take this file and then it will search for every instruction that is really useful, just to, I can say, just to not use some tokens that we don't want to use because they are very expensive. Yeah. So it's the same for the agents.md that is for Codex. So this is my rule of thumb. Okay, every bug that the AI makes twice goes inside the Claude.md file. Okay, treat it the file like a living memory, and obviously it's the same for the agents.md. So why I said previously this is a file created by Claude Code, because yeah, it's real. Claude Code will add and will edit everything in that file that is useful for it, but in the same time you can add something yourself that you think it's really useful in the future for the tool. Okay. So that is the entire setup. It takes you maybe 45 minutes for the first time, but it's really, really useful later. And this is the difference between an AI that feels useful and an AI that feels like a junior dev, a junior intern who keeps ignoring your code, your style, okay? Okay, with the project setup, let us actually do something. Here is the task I want to show you using Claude Code, and then we will see something on Codex too, if it works. The weather detail view inside our app already show us the air quality card, the sunrise. Maybe I can show you something. Yeah. Here we have the air quality card, the UV index, the sunrise with the animation, the wind, the rainfall, and another instruction, okay? Another info about the weather. Now, what I want to do, I want to add one more card that is a humidity comfort indicator that will be comfortable, a label comfortable, humid, and very humid based on the humidity percentage, okay? Small but real. It touches a UI components, a parent screen, and 3 localization files because we need the multi-language support for this app. So before I run anything, I want to show you the difference between a bad prompt and a good prompt, because this is really important, because this is where most people get poor results and then blame the code. So let's start with the bad one. Add a humidity card to the weather app. So that is a complete sentence, but it's also useless, you know, because the AI doesn't know where the cards live, what the existing pattern looks like, what your design language is, where to put strings, or how you handle damming, for example. It will invent answers to all these questions. So it's not really good, and you will see that will become really expensive for you, because we know Claude is using a lot of tokens, and we don't want to do that. And on a mobile project, we can say where the build cycle is 30 seconds if you are not lucky and not unlucky, and the simulator boot is another 20. Every wrong prompt is a minute lost. Okay. So let's go with the good version. I will show you these 4 points, but let's try something. Okay, sorry for that, but let's start Claude Code. Perfect. And now I can say I want to add a new card showing humidity with a comfort label. Yeah. Look at air quality card.ket for the pattern to follow. Same card style, same damming, same way of using string resources. And then other instruction, the card should show. As I said, the humidity percentage that is already in current weather domain model, for example. And then a comfort label. Without then, we don't need it. And a comfort label. That will be comfortable if humidity is less than 15, humid if it's between 15 and 70, and very humid if is more than 70, okay? Final instructions, add it below the air quality card, add 3 new strings to the English, Italian, and Spanish localization files. Don't run the build yet, okay? And show me the diff first. Okay, let's wait for it. Meanwhile, why this is a good prompt? Let me unpack what I just did, okay? This prompt has four ingredients, the bad one did not, okay? The first one, I gave it a reference. Look at air quality card. That is really important because this is the highest leverage prompting technique I know. Pointing at an existing pattern is worth 10 paragraphs of description, okay? The second one, I told it what data is available. So humidity, we already have humidity. Humidity is already in current weather. That prevents the AI from inventing a new field. The third one, I gave it a business logic with no ambiguity, okay? And the last one, I told it where to put the result and what not to do. Below air quality card. Do not run the build yet, okay? On mobile, every speculative compile costs you a minute and a lot of tokens too, okay? Okay, it worked. We will see the result later, but take a look here. Okay, perfect. It should create the humidity something, humidity card, I don't know. Let me check it. Humidity card, yeah. Where is it? Humidity? Ah, humidity. Yeah, understood, it's not working. This is the demo effect I was talking about. Weather detail. Looking for humidity. Maybe, no, apply. I'm sorry. He didn't apply it. You can take a look here, but yeah, let's wait. It's better. Okay, it's working. Look at the tokens, that is really important. Okay, diff applied. So if I'm looking now for humiditycard.ket, we will see that it created this card in the right place, because if we will see it, it's inside the core UI components, okay, where the other card lives. That is really important. It has the same, I don't know, container color for the card colors here, the same stroke, the same paddings too. Look at this logic, comfort text, okay? Inline when, no sealed class, no companion object, no factory function. This is exactly what air quality card does for its 5-value mapping, okay? It just does a when and looks up the string. The AI didn't invent ceremony. It mirrored the existing code. And this is important for me because I want to be honest with you about something here. When I started preparing this talk, I expected here the AI to produce something clever, like a sealed class, a type-safe phenom hierarchy, some abstraction to show off. That is the assumption a lot of us working with, that the AI will over-engineer it, okay? But what actually happened, and what happens when you set up the project correctly with a correct Claude.md file, is that the AI did the boring, correct, idiomatic thing. The lesson here is not that the AI is clever. The lesson is with a Claude.md file and some reference files, the AI converges on what you would have written by hand, okay? This is really important. So let's move to the weather detail. So he didn't edit the home screen. He edited the weather detail. So he added the humidity card. Where is it? Here, the humidity card. He added a spacer too, and he added also the strings, okay, like that, with the translations. Let's build it. And meanwhile, there is another important thing. Yeah, we have the build, so let's check it. Okay, now I can say, give it more. Yeah, I can ask for a more stretched card, but the style is the same. Okay, that is really important. Now, another thing that is really important for me is this one. This question. Before I accept this, what assumption did you make that you are least confident about? And I think this question is gold. It works on Claude Code, it works on Codex too, and on basically any agentic AI. You force it to do its own review, to do the self-review of the code, okay? So let's take a look to the answer. The least confident call is the boundary at exactly 50%. You said less than 50 is comfortable, between 50 and 70 humid, and blah, 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 which leaves 50 and 70 ambiguous if read strictly. I made 50 fall into humid, meaning a humidity reading of exactly 50 is labeled humid, okay? So it's like a code review that is basically a bug, okay? So let's return here. Take a screenshot of this slide because this single question has caused more issues, more defects for me than any other prompting technique, okay? So, let's go. Yeah, no, I want to talk about something else previously. The point here is I was not interrupted, okay? Because I have a simple question. Would this have been faster by hand? I think for this specific task, probably it's the same. Maybe 18 minutes by hand if I am uninterrupted, no? But this is not the point. I was not interrupted. So while Claude code worked, I talked about other slides, for example. Okay, so I didn't context switch between the components folder, the parent screen, the 3 localization files, 1 instruction, 1 diff, 1 review. Okay, this is the point. That was the easy case. Well-scoped task, clear pattern, no design ambiguity. Now I want to show you what happens when the task is not well-scoped, because that's the case where the choice of tools, the choice of the prompt to actually starts to matter, okay? So, for example, take a look at this. The weather repository implementation. Okay, here you have the get weather, okay? Every repository method have the same shape. We can say try, catch exception, wrap, the caller, the view model. Here we get a result weather, maps everything to the failure message. But this is fine for a demo app. In production, I think it's not really fine because we want to have more differences on the error, for example. Okay, because here all the errors, they all become the same failure. Okay. So the task is here, okay, what's the correct way to build some errors? Here are some questions, for example. Where is it? Yeah. So how many error types? 2, 5, 10? Where do you map row exception to error types? In the API service, in the repository, in the use case? Do you keep the result and the result.failure, or do you switch to a custom header, for example? And again, do you change the case signatures? Do you change the view model? Do you change the UI strings? I think a senior developer would have opinions on all of this, no? But a senior developer might still ask your team lead. I don't think the AI has a team lead. So when you give it this prompt without specifying the answers, the AI's defaults, so we can say, will determine the design. Okay, so this is the interesting part. Claude Code and Codex have probably different defaults. So this time I'm going to give the same prompt to bot and let's see. Okay, I will copy it so we will have time later. For example, I can say here, okay, let's take a look at it. I want to introduce a typed error model for the repository layer. Right now, whether repository implementation returns result.failure for any exception. That loses information, as we said previously. Add a sealed class weather error in core domain that the repository returns instead, and update the weather repository implementation to map exception to specific error types. But keep the result return type, and don't change the view models or the UI yet. We just want the data at the domain layers, okay? And let's see. Okay, he's creating a weather errors file, as you can see. He's rewriting the weather repository implementation. He's changing all the APIs. And And yeah, and you can see here we have the weather. Ah no, maybe I should upload the diff, yeah. But say it's not really important. We can see it here. As you can see here, we have a weather error file with I don't know 1, 2, 3, 4, 5, 6, 7, 8 types of error, and then we will have a mapper, if I'm correct, yeah, to all these errors based on the response code. Okay, so this is the default for Claude code, for example. Okay, I can do the same with Codex. So let's try it. Yeah, let's wait for the diffs. Okay, that's really good. I can stash everything here. Okay. No, I don't have the demo Codex clean. Okay. Wait a second. Okay. Let's try it on Codex. Perfect, this is Codex. And then let's copy the same prompt. And let it work. It's working on the project, is reading probably the agents.md file and is thinking about it. Yeah, here you can see Codex has a lot of instructions that are really useful for us. Yeah, he's creating the same file, the weather error file, because it's in the prompt. Yeah, it's not ready yet. Okay, it's editing the weather repository implementation. The test 2. Yeah, this is a different, for example, no? As you can see here, he is editing not only the weather repository implementation, not only the weather detail, as I said, but it's editing also the weather repository implementation test, but I didn't ask for it. So let's see how it's different to work with Claude Code, or Codex, okay? It's really different because here Codex, for example, it chooses something I didn't talk about. I didn't ask for the test, okay? Just to give you an info that we have some differences and we need to choose the good tool for us, okay? So let's return here. Yeah, I think we can jump here. Okay, that is the most important part of the talk. I want to be honest about the part that is hard. Yeah, reviewing AI-generated code is something different. I can say it's a different skill from reviewing code from a human colleague. And if you don't develop that skill deliberately, you will eventually ship something that is really, really embarrassing, because the kind of bug nobody puts in their productivity influencer demo, but everyone, you know, I want to give you an example. Let's see this, because we have 3 failure modes of AI review, okay? The failure mode 1 is the rubber stamping, because the code looks really good when you see it. We are talking about AI code, okay? It looks really, really good. The test pass, you hit approve. You didn't actually read the diff line by line, and that's the most common failure, okay? Because it's the one that produces the bugs that are the most, because we cannot find it. They are hidden in the interaction between the new code and the code paths you forgot existed. So the change looks fine, the new lines compile, but something is not really good. The failure mode 2, the paranoid bottleneck, that was in the first slide if I remember well, is the opposite. You become so suspicious of AI code that you look for each line and you spend a lot of time, which destroys the productivity benefit and leaves you exhausted basically. So you might as well have written it by hand. The third one, the last one, is the Stockholm Syndrome. So the AI suggests an approach you don't want to choose, you push back, and then the AI explains its reasoning with confidence and you give in, and 2 days later probably you realize your original instinct was correct. And these are the rules I now follow. The first one is read the differences in a code review, okay, not a status update. That means open every changed file. Look at what is deleted, for example, as well as what is added. You know, the deleted file are really dangerous. And then it's important, for example, because we just saw that Codex changes something we didn't want to change, okay? Then just a second, because my second screen is not working. Okay. Let's wait. Perfect. I was talking about the first one. The rule 2 is run the test, because it's important to add test for the change, but we should know when the test is added. And this is the rule everyone breaks the moment they get comfortable with those tools. Okay, it's a small change, we can go ahead. Not really good. The last one is have a what could go wrong conversation, as I was talking previously. This is a habit, basically, not a checklist. After the AI finishes a feature, before you commit, you should ask these things. What is the worst input this code could receive? What happens when the network call fails? What happens on a cold start with no cached data? I have another one for mobile specifically, that is the fourth one. What happens when the app is backgrounded mid-operation? So you can ask the AI this question, it will answer them often well, but the point is to make yourself ask them, because the AI, I know it's boring, but it's important. The AI will not work on it, okay? So a good developer thinks about edge cases, and yeah, the AI thinks about edge cases when prompted. That's the difference. This is the gap where the bugs live, okay? So the deepest point I want to leave you is with this. The code ownership is not about who typed the keystrokes. It's about who understand the consequences. That is important. When I review an AI-generated change, I cannot explain each single line, it's a failure for me, okay? These are the 6 things I wish I had known when I started, because the one is invest on your files, the Claude Markdown and the Agents Markdown based on the tool you are working with. The 45 minutes spent on them is worth 100 hours over the life of the project. The point 2 is point at examples. So look at file X, okay? It is the highest leverage point prompt structure we can say I have found. The third one is what assumption are you least confident about? You know, this is my favorite question. And for the fourth one, is be wary of unsolicited changes, okay? So if the AI edited something you didn't ask about, check it, like previously. The fifth one is test the boundaries, not the happy path, because AI generated code passes the happy path. AI generated test covered the happy path. The bugs lives in the edges, as we said previously. And the sixth, use the tool, but own the code, okay? Really important. Never approve a change you cannot explain. If you cannot explain it, you cannot maintain it. And on a mobile project, it's a huge problem. So this is, I will leave you with this one. The best mobile developers in 5 years will be the ones who learn to use these tools fluently, obviously, who built the workflows that fit their craft, who held onto their judgment and their ownership. The ones who refuse to learn, the ones who reject these tools, they will be left behind. Okay, so will the ones who use these tools but stop thinking, yeah, both ends on that spectrum lows. And I can say the middle, so the developers who treat the AI as a fast, opinionated, tireless paid programmer who needs to be supervised, those are the ones who are going to ship more, ship better, and have more fun doing it. So I hope this talk gave you a few concrete things to try on Monday. This is the repo. I will share all the slides, I think, on my website and on LinkedIn too. So yeah, you can give a picture. Thank you for that. But I will publish everything. Thank you. A special thanks to Bacarotech. I'm a member, as I said, of this crazy group. Scan the code, because Giorgio will kill me. So scan the code, please. This is our website. We have all the social pages, so please follow us. And then again, my website, if you want to see my articles that are few, like now on Medium, and the other talks I will have this year. You will find everything here. Thank you.